Hey everyone, we're just getting set up here. We'll get started in just a minute or two.
So while we're getting started, I can just kind of go over some of the Zoom controls. You'll see in the lower part of your screen, there's a toolbar. That is where you can mute yourself. So we ask that you mute yourself during the webinar. This webinar is being recorded because there was some folks that weren't able to join us tonight, so they'll get the recording afterwards. Oops. You can feel free to leave your video on, or you can turn your video off. And then we'll be taking questions at the end. You can enter those questions into the chat box. You'll see a little chat box on your toolbar. You can enter those at any time. And at the end, if you would like to ask your question verbally, you can unmute yourself.
Okay, thanks, Autumn. I think I'm going to go ahead and get started. We got a lot to cover. I think we can go ahead and get rolling here. So yeah, thanks everybody for joining us tonight. My name's Jake Lemon. I'm TU's Monitoring and Community Science Manager. I see some familiar names out there, and I see some names of folks that I don't know, but I manage a lot of our citizen science or community science work throughout our eastern region, and have spent a lot of time in West Virginia and Virginia helping West Virginia rivers develop our volunteer water quality monitoring efforts, including our pipeline monitoring program. And so this is a continuation of that effort. I'm joined by Autumn Crow with West Virginia Rivers, who's going to be covering a lot of the content tonight. And many of you have maybe attended one of our previous trainings or webinars where we've covered visual assessment, and this will be some review of that, but we are looking to hone in a little bit closer on actual stream crossings, methods, and some of the stuff to look for to get people prepped for the potential of a large number of stream crossings taking place in the coming year or so. So Autumn, go ahead and progress slides. Maybe I have the ability to do that. No, I can't do that. Okay, so this is part of our West Virginia water quality monitoring project that was started back in, I think 2012 is when we got this going. Initially looking at supporting local citizens and watershed groups and TU chapters and other interested folks in the community to monitor water quality in areas at risk from shale gas development. And as some of these larger pipeline projects were proposed, namely the Atlantic Coast Pipeline, Mountain Valley Pipeline, and then the Mountaineer Express Pipeline and some others, we adapted that protocol to support these same groups to protect their local streams and rivers from impacts from pipeline development. And so we've had folks out along several pipelines over the past few years, collecting water quality data and doing visual observations. Autumn can give you the exact number, but I want to say we submitted something close to 200 complaints to state agencies, and resulting in things from varying from notices of violations to fix-it orders, and to just sort of verbal guidance to the companies to fix specific problems. So we feel really good about the impact that the folks are having out there, and we are looking to continue to support that through this webinar. All right, you can go ahead and continue. So what are you going to learn tonight? Like I said, this will be some review for folks who've attended our past trainings, but some new content. We'll talk about the various methods for pipeline construction across rivers and streams and what specific things we can look for during stream crossing construction, both on these sort of adjacent areas around the stream and within the stream itself. We'll talk about what to look for once construction is complete at a particular stream crossing, how to effectively document pollution issues or failed BMPs, and how to report those through our program. You would progress, Autumn. So at this point, we're going to dive into some of the permits that are required, some sort of the state of where we are specifically with the Mountain Valley pipeline. And then we'll go through the different methods and things to look for. So I'm going to hand it over to Autumn for a good, and who will be covering most of that content.
Thanks, Jake. So yeah, I'm Autumn Crow. I'm the staff scientist for West Virginia Rivers Coalition, and I've been working with Jake on our pipeline monitoring program for many years now. And we've learned a thing or two over the years. So we're going to share some of that with you tonight. And we'll start by just going over the permits that are needed for Mountain Valley to resume construction. So right now they are trying to get their stream crossing permit. They have applied for an individual permit with the Army Corps of Engineers. And that allows them to dredge and fill in streams and wetlands. They also needed the biological opinion and incidental take permits from the Fish and Wildlife Service. They are impacting critical endangered species habitat for the candy darter and also the Roanoke log perch. In addition to the individual 404 permit from the Army Corps, they also need state permits from both the Virginia Department of Environmental Quality and the West Virginia Department of Environmental Protection. And in addition to those stream crossing permits, the 401 water quality certification, they also need stormwater construction permits. And those regulations are a little bit different between West Virginia and Virginia. And then the Federal Energy Regulatory Commission is the agency that signs off on the overall project and issues their certificate of need. And so while they had that previously, they have to request an amendment for their certificate because they are changing their plans and instead of open trenching, they're boring under a significant amount of streams. And so they have to request an amendment, and part of that approval for that amendment request is that the Federal Energy Regulatory Commission has to comply with the National Environmental Policy Act. So right now they are in the process of developing an environmental, either an environmental impact statement or environmental assessment to study the impacts of boring under all of those streams. And so, as I mentioned, MVP has kind of been in a holding pattern because of their legal issues. So there is approximately 500 streams that remain to be crossed. And what MVP is proposing at this time is to bore under 120 locations, crossing under 181 water bodies. And the boring lengths vary anywhere from 300 feet to 1,250 feet. And the bore pits can vary anywhere from 5 to 45 feet deep. And some of the longer borings would take up to 4 months to complete.
All right, just wanted to share a few maps that we can share with you in interactive form following the webinar. But here you see the left two maps are both stream crossings in West Virginia. The purple are stream crossings that are proposed to be completed using dry ditch open cut. And then the red and green and blue on the left are stream crossings that are proposed to be borings, whether they're conventional, which is the red, direct pipe, which is the blue, and guided conventional bore, which is the green. And we'll talk more about what these various terms mean and the particular concerns with them. On the right, we have a map of stream crossings in Virginia that was developed by the Mountain Valley Watch. And the colors here are just showing you red are stream crossings that have yet to be completed, and the green are stream crossings that have already been completed. And I think, if I remember correctly, there's stream crossing, a few that have been completed in the North Fork Roanoke River watershed, a few in the North Fork Blackwater maybe I think Green Creek as well, Little Creek, but most, as you can see, most have not yet been completed. And like I said, we can share links to these maps with y'all. You're muted, Autumn, if you're talking.
Thank you. Okay. As I was saying, so a little bit about the impacts from construction in the streams. So when the pipeline construction goes through the stream beds, they destabilize the stream banks and the stream beds. This can cause increased stream bank and stream bed erosion. They also have to remove all of the riparian vegetation, and this can result in increased stormwater runoff and sedimentation. Then dewatering the stream beds for prolonged periods when they're doing the dry ditching, that can disrupt the feeding and breeding and death of, actually result in death of species if they're not removed from the dewatered areas. So things like mussels and benthic macroinvertebrates that aren't able to move as quickly as like a fish species. And then we have seen a lot of accidental spills of fuels or drilling mud. And so that actually causes a degradation of water quality with petroleum spills and bentonite getting into the water. And then multiple crossings within a watershed just compound all of the above impacts. So we'll go into a lot more detail about this specific problems and how to identify them. So tonight we're going to talk about the different methods that MVP is going to be using to do the pipeline construction through the streams. So there's the wet crossing method, and that's when there's no water diverted and it's just an open cut wet ditch. Then there's several dry crossing methods. That's when the water is diverted. And so there's multiple methods with the dry method. There's just dry ditch. That's just a trench. There's a flume. There's dam and pump, and then there's a cofferdam. And I'll go into all of these in a little bit more detail. So the advantages to the open cut wet ditch, it's one of the more impactful, but it has its advantages. It's that it's quick to complete and it's lower cost. The disadvantages is that there is a significantly more sedimentation and runoff, and there's more impacts to aquatic life. The open cut dry ditch, this is used more on ephemeral and intermittent streams, and it's mostly used during dry conditions or frozen conditions. The advantages of this is that there's no water diversion needed, but the stream bed will have significant amount of disturbance and scouring. Another dry crossing method is the dam and pump, and that's when the stream is dammed to make a dry work area and the water is diverted around the workspace. The advantages of this method is that there is less sediment released, but the disadvantages is that it's there can be barriers to fish movement and impacts to immobile species, and there is a chance of mechanical failure of the pumps or the dams, which would cause the water to flow back into the diverted area and cause additional sedimentation and erosion. The other dry crossing method is the flume method, and that's when a dam is constructed to make a dry workspace, and then large pipes or culverts are installed to move the water from the upstream side to the downstream side. The advantages of this is that you maintain the stream flow and allow fish passage, but the disadvantages are that there, again, impacts to immobile species and habitat, and it's difficult to lay the pipeline under the flumes. The other type of dry crossing method is the cofferdam, and this is used for larger streams, and it's completed in 2 stages. So one side of the stream is dammed and the trench is dug in the dammed portion and the pipe is laid, and then the trench is backfilled and the dam is removed, and you return the flow to that area. And then the next side of the stream is dammed and the process is repeated with a small area of overlap to be able to connect the pipes. The advantages of this method is that there's minimal sediment transport and it allows for fish passage, but it's extensive in stream activity with the installation of the dams. You actually have to like embed them somehow in the stream bottom, or use like heavy weights to keep, because there's a lot of water pushing against them. And then immobile species are still impacted, as well as habitat. So those were the dry crossing methods, and now we're going to get into some of the boring methods. So there's several different types of boring methods. And this is where you drill a borehole under the stream bed and run the pipe through the borehole. There's conventional bore, microtunneling or direct pipe, and horizontal directional drilling. So the advantage of boring over open cut is that the stream bed remains intact. But there are some disadvantages. There's usually a large amount of water or drilling mud is required. And this can lead to the possibility of bentonite blowouts if you're using a lot of pressure to move that drill bit under the stream bed, and you have to use a lot of the drilling mud to lubricate the drill bit. And then if a fracture happens, then that drilling mud erupts into the stream bed. And then you have a lot of water coming into the bore pits. When you're boring, you have a pit on either side. And so you have to remove the water from those bore pits and put it into a dewatering device. And those can actually fail. And then also the drill bit can actually get deflected by large boulders in the substrate that you're drilling through. And so that can cause problems. So a little bit more about the conventional boring method. You have a pit on either side, and the bore pit and the receiving pit. The pits are excavated to whatever depth is needed for the pipeline to pass under the stream channel. And then the boring machine is lowered into the pit and drills a borehole under the water body with a rotating auger. And then once excavated, the pipeline is pulled through the bore pit to the receiving pit. The guided conventional bore is similar to conventional bore, but there's a small guided pilot that's installed first, and this pilot allows it to be steerable. This method is used in longer borings because the drill bit is steerable. Bentonite drilling mud mixture may be required, especially for longer borings. And after the pilot hole is drilled, the auger with the pipe string follows. So you drill the hole and then you push the pipe through. And generally for this type, you require 24-hour operation once it's started, because you don't want the hole that you drilled to collapse. So the other method that's being used is the direct pipe boring method. And this is kind of a combination of horizontal directional drilling and microtunneling. So you have a microtunneling boring machine that installs the pipe in a single pass. It's lower horizontal directional drilling, but the drill bit is still subject to deflection from cobbles and boulders greater than 14 inches. And the operations must continue nonstop to prevent the tunnel to collapse. And this method, this is the method that they're using on the Greenbrier River, and it would require about 500,000 gallons of water and slurry mix to complete the operation. So now we're going to get into some of the best management practices during pipeline construction. And these are practices that are used to reduce erosion and control sediment. So we have slope breakers or water bars. These are used on steep slopes to divert the water off of the right of way to reduce erosion. And then you have the trench plugs. These are also used on steep slopes to prevent the water from just tunneling down around the pipeline. So the trench plugs stop the water and then it kind of disperses. And then you have mulching and mesh matting. This will just provide a protective cover for the disturbed soil and reduce the area of impact between the precipitation and exposed soil to reduce erosion. So some of the BMPs that are used specific to stream crossings. We'll have a timber mat bridge that's put in place to drive equipment across the stream. So you're not driving equipment back and forth through the stream bed. So generally, the first thing that they'll do is install a timber mat bridge to get their heavy equipment across the stream. And then you'll have to have sediment barriers around the bridge, the edge of the bridge, to keep any rainfall that occurs on the bridge, to keep any kind of dirt and soil that's been collected on the bridge from just flowing over the bridge and into the stream. So you have to have sediment barriers on all sides of the bridge. And then silt fences protecting the stream, and hay or mulch around any disturbed soil areas. And then some of the BMPs that are specific to borings. I mentioned the auger that's going to be drilling, and then the bore pits. So you'll have, when you dig the pit, you'll have bore pit spoils, and then you'll have the drill cuttings from the auger. So those stockpiles of soil from both the bore pit and the drill cuttings need to have some kind of protective cover on them to reduce erosion. And then the dewatering devices that are in place, these are generally made out of hay bales and geotextile fabric. And the idea is that the water is pumped out of the trench or the bore pit and into these dewatering devices, so that it's all sediment laden water and you really don't want that getting into the stream. So they put them in these dewatering structures so that the sediment settles out and then the water can flow through the geotextile fabric. So for additional information on the BMPs that are in place for pipeline construction, we've provided some links here, and you'll get copies of these links. And so the purpose of this program is to have citizen observers. You know, we don't have enough inspectors to cover all 300 and some miles of the pipeline construction. And so the citizens, you guys that are learning about this stuff, can serve as the eyes and ears on the ground to be able to identify pollution events as they occur and then document them and report them so that we can report them to the agencies, and the agencies can send their inspectors out to follow up on them. So you guys are really the first line of defense that these streams have by being out there and keeping an eye on them and making sure that the construction is happening properly, that their erosion controls are in place, and that there's no sediment entering the streams. So what to look for at the stream crossings? The stream flow should be diverted away from the disturbed ground. Generally, they're not doing any wet crossings. All of their crossing methods are dry ditch or borings. So the stream flow should be diverted away from disturbed ground. And then you want to make sure that the dewatering devices are working properly. So you can see in this photo, this is a photo from the Pipeline Air Force, and this is actually the Stonewall gathering line. And you can see that the dewatering device, they were doing some boring under the road and under that small stream, and the dewatering device failed. So all of that sediment laden water was leaving the dewatering device and entering the stream. So you want to make sure that the dewatering device is working properly, that the BMPs are in place around the stream channel, and then you want to compare upstream and downstream conditions and note whether there's muddy water downstream and there isn't upstream. And if there is, then that's definitely a problem that you'd want to report. So another thing you want to look for, if you see stream water discolored with a sediment plume, then you're going to want to, then something is wrong, and you're going to want to investigate upstream to identify the source of the sediment, because it may not be from construction activity. It could be, cattle in the stream or something like that. So if you see stream discolored, you want to investigate upstream to find the source of the sediment. And then I mentioned earlier the bentonite blowout or frack out. So here's an example of what a stream looks like when that occurs. So you have all of the drilling mud, the clay. It's bentonite clay. So it's not necessarily toxic, but it will smother the habitat the same as it would sediment. So all of that bentonite clay in the water is going to be a problem, and that's what you would want to look for and report. And then when you have the bore pits or the trenching that's occurring below the water table, the groundwater is going to enter the trench and the bore pit, and that's going to produce sediment-laden water. They'll pump that out of the trench or the bore pit into the dewatering devices, but we have seen that they are not installed properly, or they're not big enough and they can't handle all of the water that's being pumped into them. So they oftentimes fail and release sediment-laden water into the stream. So you also want to look for sediment-laden water that's bypassing their erosion controls. It can go over, it can go under, there can be holes in it, and it can go through. There's a lot of ways that these erosion control measures fail. The filter socks and the silt fences, there's just not enough area for them to cover to be able to catch every stream of sediment-laden water. Another thing to look for is oily film on the water surface. That could be indicative of a petroleum spill. The one thing you will want to make sure there's some microbial processes that occur in wetland areas that can produce oily sheen that's a natural occurrence. And the way you tell that is by poking a stick in it, and an oily petroleum sheen will kind of congeal back together. And when you poke it with a stick, if it's the naturally occurring sheen, then it'll kind of get like a blocky structure. And then the other thing that we've seen is that there is earth disturbance to the edge of the water body, and there's no erosion controls in place, and all of that loose sediment is going directly into the stream. So if that is the case, you definitely want to report that. Another thing to look for is bare soil with no mulch, or mulch that's been washed away due to wind or water. There really shouldn't be bare soil exposed without any protections, because once the precipitation hits that bare soil, it's going to erode. And then failed BMPs, these silt fences aren't designed to hold back whole mountainsides. So, a lot of times there'll be a slip or a slide and the BMPs will be overwhelmed. So this is an example of what a well-kept pipeline construction site should look like. They've got the water bars, the trench plugs, they've got perimeter controls, they have multiple silt fences around the stream. They've got their barriers around the timber mat bridge. Here's an example of bad pipeline construction where they have no erosion controls going down the right of way, and that's just caused a lot of erosion. And then a really bad construction site is when, you know, the treatments just get completely overwhelmed and all of that muddy water enters the stream. So what to look for following construction, you want to make sure that the area has been vegetated. If the vegetation is not at 70%, then that is actually a violation of their permit requirements. You want to make sure that that the area is stabilized. If there's failing slopes or erosion gullies, then something is not working properly in their erosion control plan, and they need to update it to address the erosion. And then you want to make sure that the stream banks aren't being undercut and eroding, that the stream banks are all stabilized with some kind of vegetative matting until vegetation can reestablish. And then another thing to look for is whether the stream substrate is similar from downstream and upstream from the crossing area, because if there's a lot of sediment in the downstream area, then they've done something wrong. And that's it for me. I'm going to turn it back over to you, Jake.
Okay. Before I jump in here, there were some few questions in the chat that I thought it might just make sense to do them quickly right now. I think there's things we can address pretty quickly. I might get your perspective on them as well, Autumn. So the first one from Paul: is boring more or less impactful than channeling or trenched crossings, or are they both equally problematic? My take on that anyway is that there's probably site-specific characteristics that would dictate which of those methods would be preferable at a particular stream crossing. The benefit to boring is that you're not, if it's done correctly, you're not disturbing the stream bed, but there's a lot of water and bentonite, slurry to deal with, which can lead to problems. I used to be based in Pennsylvania, and we had the Mariner East pipeline come through and had major problems with bentonite blowouts or inadvertent releases that led to a lot of violations and water quality impacts in the state, or in that region. So there's concerns with both. I don't know, Autumn, if you have anything to add to that. You're muted still.
Yeah, I would just generally agree. There can be problems with both. And the problem with Mountain Valley Pipeline is that, we have seen that their contractors are, cutting corners to make up for lost time. And so they really don't have a good track record. So unfortunately, we're concerned about all of the crossing methods that they'll be using.
And before you mute yourself, I think the next one's a better question for you. Are they boring only under perennial streams? What about ephemeral streams?
Yeah, they are boring under a lot of streams and wetlands, and it's not really categorized by, the amount of water flowing through them. It's more a question of whether there is enough area for them to actually be able to put all of their boring equipment on site. So they are boring under all types of streams: ephemeral, intermittent, perennial. I don't know the breakdown off of the top of my head, but they're boring under multiple orders of streams. The larger rivers are generally they're generally boring under the larger ones that have a larger floodplain, where they can set up all of their boring equipment. The thing that prohibits them from boring is if there's steep slopes on either side, and they're not able to actually set up their bore pits. And so in that case, they would be trenching.
And do they consider groundwater, where the water table is in those assessments? That came up as well.
Not really.
Okay.
Not that I've seen. I mean, we've been asking for them to assess the groundwater impacts, and we haven't seen anything come out from the company that fully assesses the impact to groundwater. They basically estimate where the groundwater table, where the water table is, and that determines how much dewatering they'll have to do, but that doesn't necessarily determine the type of boring or the type of crossing.
Okay. Okay. I want to keep this thing moving, but but we'll address a couple more questions real quick. How much area do they need to bore? Stage the equipment? Is there a standard size area?
That's a really good question. I don't know off the top of my head. I know they generally need to have a somewhat level area, but I couldn't tell you like specific acreage of area that's needed. But they do need a good area to stage their equipment. I'm just not sure of like the exact size that they would need.
Okay. All right. Now I'm going to do one more and we'll try to address any other questions at the end here. Says, are sediment laden water and slurry with pumping basically the same? So sediment laden water is kind of an agency term for when water is running down the surface of the ground surface and picking up sediment from a work area or otherwise, and washing that into going into a stream. Whereas a slurry is sort of a mixed pumping mix that's used for conventional boring and other methods to lubricate the drill bit. So it's sort of like a manufactured sediment laden water. And so they're a little different as far as their like composition, but the concerns are pretty similar in that, they have the potential to degrade water quality and smother habitat and things of that nature. So anything to add on that, Autumn?
No, that pretty much covers it.
Okay. All right. I'm going to keep moving here.
Oh, Jake, you're muted.
So I'm going to move on here. Looking at when to conduct assessments, how to do them, how to document things was what we're going to cover here. So when to conduct assessments, this will look familiar to people who have participated in our trainings in the past, but most important time is during and or after moderate to heavy rains, because that's when you're most likely to see impacts. A lot of what we're looking at and identifying are sediment and erosion sedimentation impacts. And when those occur is when we have rainstorms. So getting out there in the rain or directly following the rain is the best time to identify if there are issues occurring, at least as far as issues occurring that have impacted the stream. You can get out at other times, obviously, and a lot of times you'll be looking for issues with the erosion controls or failed erosion controls. Weekends and holidays are a good time to get out. State or other inspectors are less likely to be at the sites at those times, so there's less eyes on the project. So it's a good time to check out sites, both during and after construction. Autumn talked a little bit about what to look for while construction is occurring and during restoration. Really, until the revegetation is complete and the area is stabilized, it's good to have eyes on it because there's still the potential for problems. There's pipelines that in West Virginia that were completed multiple years ago, a year or two ago, that still aren't released from their permits because their erosion control practices aren't up to snuff and are still they're still seeing water quality issues. So stand with it. You can continue, or next slide. Just some general rules and safety considerations. The big thing is that your safety is more important than anything you're doing through this program. So don't put yourself in any kind of dangerous situation in order to collect information through this effort. Be courteous to landowners, pipeline workers, or others that you meet avoid confrontation. You know, folks are may come up and ask you what you're doing, and obviously an opportunity to share information, but just try to be courteous and avoid confrontation. Respect private property. So if you're doing, you know, you're looking at, sometimes it can be hard to actually get your eyes on the stream crossing site. And if you can do it from a public road or from private property where you have access, that's great, but don't trespass. Don't enter active pipeline sites. That, you know, that seems to be that's an obvious one. Like I said, stick to places where you have legal access. Don't place yourself in a physically dangerous situation. So, you know, scaling a steep cliff or wading extremely high water, anything like that. So just be smart out there, use your common sense. And then if you see anything that might create a public health or safety hazard, don't contact us, contact your local emergency management service. And, you know, I don't necessarily have great examples for what that might be. You kind of have to use your common sense there, but it could be, you know, like a damaged pipeline or something like that. You know, things that would be of immediate concern. You can continue. So how to document issues. The biggest thing is photos and videos. Visual evidence of issues is the most useful tool we found in working, getting agencies and working with agencies to respond to issues on these sites. It's good to have perspective. You know, if you take a like a close up of some muddy water, that tells us hardly anything. Or if you take a super close up of like a ripped silt fence, that doesn't tell us a whole lot. So you want to, you know, those close ups can be useful, but you want to compare them with wide angle photos that give context to what you're looking at. If we have sediment laden water entering the stream, try to show where that water is coming from. If even better, if you can show, you know, a failed erosion control where that water is coming from. So the more context to, you know, provide an understanding of what's going on and where it is, the better. Look at the stream both above and below the impacted area. You know, if we're seeing issues on the work site, we can document. We have very muddy water downstream and clear water upstream. It's just good added documentation to have. If we have a major sediment issue, it's a good idea. If you document sediment in the stream, it's a good idea to identify the source. So that could be traveling upstream to figure out where it's coming from. And also the extent, you know, if you have the ability anyway to access a stream, you know, if there's a road following it or whatever, you know, it's useful to understand if that extent of that sediment laden water, at least visually in the stream, is, you know, 100 yards or 10 miles. So useful information to collect. Go ahead. Most of us are using smartphones nowadays, but if you're using a digital camera, make sure the date stamp is correct. If you're, you know, turn on your location services if you're using your smartphone. That can embed the GPS coordinates of where you're taking the photo in the metadata for the photo, which is useful. When you're reporting, you need to describe what you saw. Just, you know, photos themselves are useful, but it's super helpful to have your take on what was going on out on the stream, just to provide added context. A couple things that, just like I kind of mentioned before, if you capture a plume of muddy water entering an otherwise clear stream, that's an effective photo. You're showing that there's something entering the stream that wasn't in there before. And if you have the water quality violation with a source behind it, that's super effective. You know, we get those every now and then where you can see the failed silt fence with the sediment laden water overtopping it or going through it and then entering the stream. That's like the most effective picture that you can take if you're able to get that perspective. Okay, go ahead. Location information, super important. You'll want to take GPS coordinates. There's tons of apps that do this, including Google Maps, which many of us probably have on our phones. Most of these will record coordinates even when you don't have cell coverage. The best format that we prefer is decimal degrees. If you send it in a different format, we can convert it. But if you can't record the GPS coordinates, we just need very detailed instructions to find the location. You want to make it easy for the state inspector to be able to figure out where you saw what you saw. And then just FYI, we're working on a smartphone enabled form based on the Survey 123 platform. That's a smartphone app that will basically facilitate the collection of the GPS coordinates and your comments and notes on the issues and photos. It'll be basically a smartphone form where it'll grab your location, you can write your notes, take your photos, and then automatically submit it to us, just to sort of streamline things rather than attaching photos to emails and that sort of thing. So that's coming out, and that will serve West Virginia in summer of this year, and something that you can use as a tool in this program. So stay tuned for that. You'll be on our email list, so we'll send that out when it's available. Okay. So if you're utilizing this training, we ask that you make reports through our reporting process rather than contacting the agencies directly. We've developed a pretty good, a good rapport, especially in West Virginia, with the environmental agencies, and have been submitting submitting reports of issues for the past probably 4+ years now, I would say. And I think we have a good track record of getting a good response to our submissions. So what we ask that you report through us. There's different, it's kind of different based on what state you're in. If you're in Virginia, the reporting is done actually through the Mountain Valley Watch, and I've provided their email address here. We'll send these slides so you can have a link. They do have an online incident report form as well. If you're reporting in West Virginia, we'll ask that you email Autumn. We provided her email address here, and then or use that smartphone form that will be coming out this summer. So you can go ahead to the next slide. When we receive these reports, we review them to determine if it's a reportable incident. Sometimes we'll get reports that will be things where, I can understand why it was, where we can understand what was the concerning thing, but there's not necessarily a violation, or we can ask for added information from the volunteer based on our experience working with state agencies and knowing the type of information they would want. So we can basically help you sort of craft your report in a way that will ensure a better response. And so once we kind of work through that process, we'll submit it to the appropriate agency and then follow up with you with the agency's response, which, there's sort of usually a short-term response of, saying that they got it. And then, down, a few days or weeks or whatever down the road, we have an understanding of what happened with the inspection that was done in response to the report. And then we do have networks with other monitoring groups that do things such as, aircraft or drone-based imagery or water quality rapid response teams, things of that nature that we can deploy as needed. So that's sort of the process. It's like you guys are out there, you're the eyes and ears on the ground, you're collecting the information, you send it to us where we help you sort of format it and get it in a good, ready to send on to the agency so that we can get hopefully a quick and effective response. So next. And just wanted to share this one other mapping resource for you, another Mountain Valley Watch tool, which is their Mountain Valley Watch dashboard, where they catalog a lot of their reports along the Mountain Valley pipeline. I'm suspecting that many of you are along the Mountain Valley pipeline who are attending this webinar, so this could be a useful resource for you all. That link will be in there when we send out these slides. So I think that's all I had. So the basic idea, again, is just get good photos, document the location, give a good description of what you see, and get that to us so that we can help you submit it. So with that, I think we'll open it up for questions. We have about 10 minutes or so. Maybe I can go through the comments right now. Looks like there's some more. Hopefully I didn't miss any here. Can you describe a floating intake? Is there a high risk for smaller streams to be dewatered with water withdrawals with this method? Autumn, is that something you're familiar with?
I have never heard the term floating intake, unless it was related. The only intake I know of is related to drinking water. So
yeah, I haven't heard that term either. I'm guessing maybe it's with a dam and pump method or something like that, where you have an intake. Annie, yeah, if you want to follow up with us, we can help you dig in on that though. I see, who do we report sediment and inadvertent release problems to? I think that got covered probably after this comment was made. So you obviously have the right and ability to submit that to DEP. But like I said, we've got a good process where we work with you all to submit those and address those issues. Our drone's a good tool for observations. There's a group in Virginia that did the Pipeline Compliance Surveillance Initiative who used drones quite a bit looking at the ACP. I suspect there's some of that going on the MVP as well. They can be a good tool, I think, and I'm no expert on navigating the legalities of that, so I don't want to go down that rabbit hole, but I can definitely, I have a couple contacts that we can connect you with. If you want to, our email, Autumn, if you want to pull that screen back up, is in that last slide. If you want to send me an email, I'll connect you with somebody who can help you with kind of dig into that a little bit. And then do you find any benefit to calling the National EPA Spill Hotline to report problems? That's not something I've done. Autumn, what about you? You're muted.
Muted. I have no experience with contacting EPA. I find that our state agencies, are usually more in the know and more responsive with pipeline construction. However, if it's something significant like a fish kill or a petroleum spill, I don't see any harm with contacting EPA, but generally, our DEP, environmental enforcement, when we submit complaints to them, they're usually out there within 24 to 48 hours. And if it comes in on the spill line, then they try to get out there, immediately. So yeah, I don't know. I don't have any experience with contacting EPA, but I know that our state agencies are fairly responsive.
Okay, are there any things we should report to DEP, DEQ, or Army Corps before they give approval to either type of crossing? Autumn, I'll have you give your perspective to this, of course. The main thing is that I can think of is, where there's already disturbance that's occurred, if there's continued issues, where they've or on specific streams was added. So yeah, if there's particular disturbance and there's continued issues with work that's already taken place, I think that's useful to know. Autumn, do you have anything, and I don't know, Chris might be getting at if there's like site characteristics that would be useful for them to know about in the permitting process. Maybe that's something that you could speak on a little bit.
Yeah, there is an open comment period and for the Army Corps individual permit. So that might be what this person is alluding to. And yeah, if you know of specific streams that have already been crossed that are still experiencing any kind of erosion, sedimentation, degradation of the water quality or the stream banks, that's definitely something that you would want to put into your comments. And if you have reviewed the permit and you know of the type of crossing and you have concerns about the specific method, maybe they're planning to bore and karst, that's definitely something that you would want to put in your comment as well. Any other questions?
Is there a clearinghouse that details where the active sites are located? So I'm guessing we're talking about active stream crossing locations. Yes, okay. So based on my experience here, there's not. The way I find out about these is through volunteers like you all telling me that something's going on in a particular watershed. I don't know if perhaps there's some online way of finding that information. I doubt it's easy to navigate. Autumn,
Mountain Valley Watch is probably the most up-to-date website. They have aerial photography where they have planes that do flyovers, And so from that, you can see which areas are currently under construction and which areas have been partially restored. So yeah, I would say, as I don't know that they have the most up to date of, like, you know, these are the areas that are under construction, but you can look at the aerial photography and see based on that whether it's active or not.
Yeah. Yeah. Oftentimes I hear people, you know, I'll get an email from people, or I'm sure Autumn gets these too, where they're staging pipe or staging equipment in a particular watershed. And that's usually one of the earlier indications that things are about to happen.
Any other questions? Did we get through all of the previous questions?
I think so. Well, if I'll read through them again and see if I missed any there. Well, but folks, feel free to add questions to the chat box as they come up.
Well, I just want to thank all of you for joining us this evening and being willing to, you know, be watchdogs for all of our streams and rivers. We really appreciate all of you being out there and being our eyes on the ground.
Yeah, absolutely. And, you know, this thing is designed to give you information to help you all do that type of work. And I know many of you probably have a particular stream or watershed that you're concerned about and where that, you know, and that where you're wanting to keep an eye on. But if you are just generally interested and you don't know where we need this type of oversight, feel free to reach out to Autumn and I. I'm going to put our email in the chat box as well. And it'll be in the slides. We will send out the slides as well. So feel free to reach out if you need some direction on where this type of work is needed. So thank you so much for your interest, and don't hesitate to reach out with any other follow-up questions or anything.
Thanks, everyone.